Okay, today we are going to talk about velocity when motion is a circular motion, is motion in a circle. So previously we talked about speed. So if you remember, velocity, you can talk about average velocity or instantaneous velocity. We will say we will refer to instantaneous velocity at a point on a circle. Okay, so let's look at what we will mean by velocity. Well, something is going in a circle. So if it's here at some instant t, and we want to know what the velocity of it is at that instant, well, we need to know the speed, how fast it's going, and which way it's going. So velocity means velocity has two parts to it: how fast, and that's the speed part, and which way. That will be the direction part. So if something is going in a curvy path, the direction is not very clear. We use calculus and other means to come to this conclusion. The direction is actually at this point the tangent to the circle. So it will be in this, along this line, tangent to the path through this point at time t. So if it's going as counterclockwise like that, if it's moving next, so the direction will be that way. So if I was at the same point, but was going in a so I was same point at time t, but so that's the circle. Then this is the tangent, and if I was going this way, if I was going clockwise, and this will be like a counterclockwise, then the direction, I'll be still moving in the circle, but when I'm at this point, the direction would be this way. This would be the direction of velocity. So you can see the direction of velocity is along the tangent, but which side of the tangent depends on which way in the circle I'm going. Direction of velocity. So let's see, if I'm going in a circle and I'm at two different points in a circle, but I'm going at the same speed. So if I'm going in a circle this way, say I'm going at 4 meters per second. So I'm going at 4 meters per second. No matter where I am, I'm at 4 meters per second. 4 meters per second. Over here also. So over here, if I look at it, the velocity will be this way. So I'm at velocity at a. So this will be velocity at a vector, and if I want to draw an arrow to scale, we'll just say, well, this will be this is my length of the scale, so this vector will represent the velocity at a. Well, if I'm over here, let's say I'm over that point b, well, I'm still going at 4 meters per second, and the tangent here is this way, so I will use the same scale to draw the velocity vector there. So this is going to be, this velocity vector will be v at b. Well, what do you think is going to happen if I'm over here? Over there, you might say I should draw first a tangent. So, well, how do I draw a tangent over there? Well, tangent is 90 degrees to the line that connects to the centers. So I'll draw this line to that point C, and then I'll draw 90 degrees to this line, and that's the way you discover tangent. So that's the tangent, and I want this scale. So from here I will have 1, 2, 3, 4. So that would be velocity at c vector. So you can see the velocity vectors in kind of pointed in different directions in space. So if this was like a north and this was east, then this is pointed north and this is pointed west and this is pointed somewhere southeast direction. So the direction observation is even when speed is constant, velocity is not constant. And so, wait a minute, why is velocity not constant? Well, velocity is not constant because the direction is changing. The direction is changing. So you can see that there will be acceleration even when velocity speed is constant. There will be acceleration even when speed is constant. And we can study a lot of constant speed circular motion. So if something is going in a circle with constant speed, if it's the case, then we actually give a name to this kind of motion. We call it uniform circular motion. Clearly, if the speed was also changing, then you will have additional acceleration, but there will be acceleration here, and that will be the subject of next video. So I'm going to stop here, and we're going to take it from here. We'll look at the uniform circular motion. We'll have uniform circular motion, and we'll have accelerations. We're going to talk about acceleration that we see in a uniform circular motion. So I'm going to stop here.